All right, good morning, everyone. So, before we start, some reminders first. We will have problem set number 2 later this week. Actually, it will go live on Canvas on, actually next week pa pala, November 29th at 8 a.m. And it will be due on December 1st, right before midnight, 11:59 p.m. And the coverage for that problem set would be the principle of mathematical induction until what you did in the labs yesterday. So hanggang sa algebra of set. So that will include the axiomatic development of set theory, and then together with the basic operations and basic relations on sets. So hindi pa kasama dun sa second problem set yung i-discuss natin today. That will be part of the third problem set, which will come soon. Kasi ilang weeks na lang ba bago matapos ang SEM? I think we just have 1, 2, 3, 4. We'll have about 4 weeks, 4 weeks and change before the end of the SEM. So kailangan pa natin pagkasyahin yung tatlong problem set sa susunod na mga linggo. So it would be a little bit tedious, but the nice thing about this problem set is that the coverage is not that long as the first problem set. So probably we'll have less questions or less things to prepare for. All right. So I also made the appropriate changes or adjustments in the deadline. So that means, let me see what would be due next week. So all right, so we have something due on the 26th. That would be worksheet number 8. So that would be on Friday, and then probably worksheet number 9 will be postponed kasi November 29 pala yung start ng ating problem set, and I scheduled worksheet number 9 to be due on November 29. So that will be moved, or it might also be waived. Tingnan natin kung ano yung mangyayari. But that's for us for now. So for today, we'll start a brand new study guide. Dahil medyo patapos na nga yung SEM, and I'm afraid I will not be able to finish the coverage of the course kung we will continue with the same template every week. So probably from now on, I'll ask our lab instructors to finish discussing some of the modules. So para makahabol tayo ng konti at para hindi tayo nagmamadali in the lecture. Okay? But before we start this brand new module, which is which is about unit 3 in the second volume of the Math 101 Vortex, siguro nakalimutan ko lang banggitin, or actually hindi pala to nakasama sa um, sa module for last week, yung index sets, yung konsepto ng index sets, which is included in worksheet number 8, and probably gagamitin din natin siya later, specifically in this discussion, yung konsepto ng operations on index sets. All right? So dito sa index sets, or with a family of index sets, we consider a collection or a family of sets. Say tawagin natin siyang curly A. Okay? So si curly A, sabihin ko siya ay comprised of sets, say A1, A2, A3 until AN, for instance. So we're considering curly A to be a finite collection of sets. Okay. Now we can define the union and intersection of all elements of these sets using our usual notation for the union and the intersection. So pwede kong sabihin na say set capital U would be A1 union A2 union A3 until union of AN. Okay. By the way, guys, can you see my screen? Kasi hindi siya nag-register pala sa monitor ko. I'm
Hindi
writing
po, sir.
something. Ah, hindi. Okay.
Lang po.
Thank you. So let me retry it again. Okay. So I hope you guys can see it now. Okay. So nag-consider ako ng isang family of sets. Tinawag ko siyang si curly A. Ang laman niya ay si A1, si A2, si A3 hanggang kay AN. So yung mga A sub I sila ay mga elements ng set. Okay. Now, we can define the union in the usual notation or in the usual way we write unions. So, ang union ng lahat ng members ni curly A ay A1, union A2, union A3 until union AN. Although we said that the operation union is a binary operation on the set of or on sets, all right? So, ibig sabihin, at a time, dalawa lang yung pwede nating ipag-union. But thanks to the associativity of union, okay, hindi natin concerned kung sino yung una nating ipag-union. So supposedly, this should look like A1 union A2 kasi dalawahan nga lang yung pinag-union natin. And then yung sagot sa A1 union A2, siya yung i-union ko sa A3. Okay? And then, so this is counted as a single set. This is another single set. So I can take their union. So may parenthesis pa dapat dyan hanggang dun sa dulo. Alright? Kasi at the time, dalawahan lang yung pwede nating i-union because union is a binary operation. But again, the operation union is associative thanks to the associativity of the connective or. Okay? So ibig sabihin, hindi nagma-matter kung sino yung ipag-union ko muna in a long series of taking the union. So kaya pwedeng i-drop ko na yung grouping symbol. Okay? Now, a more concise notation for the union of the sets kasi ang pinag-union lang naman natin ay yung mga elements ni curly A. Pwede ko itong isulat as the union of all set A's such that A belongs to curly A. Okay? So, ang ibig sabihin lang niya, kinukuha ko yung union ng lahat ng set A's. Ang tanging requirement ko lang dun sa set A ay sila ay member ng curly A. So, kinukuha ko lang yung union ng lahat ng members ni curly A. So, pwede nyo tingnan, ito yung dummy variable para dun sa mga sets that na gagamitin natin dun sa union. And then, ito na sa ilalim ng big union. Okay? So, siya yung parang criteria kung kailan kasali siya dun sa mga EU union natin. So, this means that as long as set A is a member of curly A, then kasama siya sa union. Okay? So, pag in-expand nyo to, okay, ibig sabihin, umpisa ko si A1, member ni curly A. So, pwede siyang maging isa dun sa mga A's na kasama sa union. So, nandun siya sa A1. Si A2 na kay curly A din, so kasama rin siya dun sa union. Okay? Now, aside from this, we can also use the notation similar to the summation notation. So, pwede ko ring isulat na union ng mga A sub i's I going from 1 to capital N. Ibig sabihin naman ngayon, i-union ko yung mga A sub i's where I ranges from 1 until N. So kasi yung curly A natin ay from A1 until AN din. Okay? So in this way, makikita natin yung mas madaling pagsulat ng union. Okay? So actually, curly A could contain infinitely many sets. It doesn't matter. So pwede ko itong gawin pa rin. Ito yung pinakamadaling notation kasi kahit infinitely many yung elements na curly A, pag sinabi kong union of all A such that A is in curly A, kasama na dun sa union lahat ng laman ni curly A, kahit infinitely many pa sila. Okay? Now, kung infinitely many to, so ibig sabihin yung n, papalitan ko lang ng infinity para makuha ko yung union ng lahat ng mga AIs I going from 1 until the n. Okay? So this works for the union and this will work for the intersection too. So I can have the set I to be the set A1 intersection A2 intersection A3 until AN. So I can write it more concisely as the intersection of all A's such that A belongs to curly A, or also the intersection of all A sub i's I ranges from 1 until N. Okay? So I hope this helps you with I think one of the problems in worksheet number 8. So is that clear, guys? Okay lang ba? So think of it as a brand new notation, okay? Para sa pagsulat ng mahabang union at mahabang intersection. Okay? Okay, so I hope this is fine. Walang questions? Okay, Daniel, you have a question?
Sir, ano mangyayari, sir? Yung A, parang yung intersection ng B, ay, wait, yung A, yung nasa right sa symbol, sir. Yan,
Ah,
sir. Magiging B intersection A, ganyan.
pwede rin. So, halimbawa, you're saying magiging ganito siya. Intersection ng mga B intersection A,
Yes, sir.
A element of curly A.
Yes, sir. Yes, sir.
Okay, so kung ganito yung itsura, so ibig sabihin yung intersection, nagdidepende lang siya or titingnan nyo yung nasa ilalim ng intersection. Yung nasa ilalim ng big cup na notation, siya yung nagsasabi kung sino yung nagbabago sa bawat iteration ng intersection. So ibig sabihin nito, we are taking the intersection over all elements A of curly A. So ang papalitan lamang natin ay yung mga elements A dun sa kanan o yung mga sets A dun sa kanan. Si B, dahil wala naman siya dito sa defining criteria, hindi siya mapapalitan. So you can think of it as a constant. So if our curly A is still this, kung ang laman ni curly A pa rin ay si A1, si A2 hanggang si AN, so itong intersection na to, ibig sabihin siya ay si B intersection A1 kasi si A1 ay member ni curly A. Then intersection, okay. So itong unang set na to nakuha ko by replacing capital A by A sub 1 because A sub 1 is an element of curly A. So A sub 1 qualifies as an instant of the dummy variable capital A. Tapos itong intersection na to manggagaling kasi I'm taking the intersection of all B intersection A's. Okay? Now yung pangalawa, meron kang B intersection A2, then intersection B, intersection A3, and so on hanggang makarating ka sa B intersection AN. So napalitan yung A, yung dummy variable A, kasi ito yung indicator na si A ay dummy variable lang. So it is standing for elements of capital A. So sa expansion itong notation na to, papalitan ko lang yung dummy variable by all members of curly A. Okay? Pero si B, dahil hindi siya dummy variable, so gagamitin ko siya sa bawat set na nandun sa intersection. Okay? So is that clear?
Yes, sir. Thank you.
Okay. And of course, this also work if this is a union, if it is a set difference, if it's a complement, pwedeng A complement yan. So intersection siya ng A1 complement, intersection A2 complement, intersection A3 complement, and so on. Okay? So maraming iterations itong notation na to, but I hope you can extrapolate the process from this or extrapolate the pattern from this two examples that I have given you, or actually three, including Daniel's example. Okay. So any other concerns about index sets? Makikita pa rin natin siya later. So hopefully clear na yung definition niya. Notation lang naman siya. It's a more concise way on how to write these sets. Okay. All right. So if there are no questions, then let's move on. Of course, this would be moved. Okay. And then I guarantee you this would be moved further than November 29th, so we can focus on the problem set or preparing for the problem set this week. Okay. So our main topic for today is, as I'd mentioned, chapter 3 of the second volume of the Math 101 worktext, and it's about relations and functions. So basically, at the end of this module, you're expected to be able to differentiate or to define relations on sets and determine whether a relation is an equivalence relation, and probably also prove some theorems regarding equivalence relations. Okay. Now, remember last time we talked actually hindi pala last time, kahapon lamang, you discuss the Cartesian product of two sets. So maybe the introduction of the cross product is highly technical yesterday in the labs. Pinakita lang natin kung paano na-construct yung Cartesian product o yung cross product ng dalawang sets using the Zermelo-Fraenkel axioms, and how did we define ordered pairs technically, all right? So I'll assume that you already know them. So for the rest of the discussion, we will just denote ordered pairs by simply the usual notation that you have seen in AMAT 19 or Math 20. Hindi na natin siya titingnan as the set containing A, comma, set containing A, comma, B. Okay? So this tedious definition only shows na hindi pwedeng pagbaligtarin yung AB. So, kasi kung titingnan nyo, kung naka-ordered pair lang siya, you might think na, okay, this might be the same as B, comma, A. But if you look back on how this is technically defined, pag pinagpalit nyo yung order ni A at saka ni B, hindi na siya magiging equal sa set na to. So you're getting a different set. So as we have seen, the ordered pair A comma B is not necessarily equal to the ordered pair B comma A. Kaya nga ang tawag sa kanya ay ordered pair. So pag nabaligtad yung order, you get another distinct object. Okay? Now, we say that the Cartesian product of two sets A and B, or the cross product, is denoted by this symbol, A cross B, and its element will just be all ordered pairs whose first component comes from the set A, and the second component comes from the set B. Okay, there are some typos in this the discussion of the Cartesian product in the work text, so hopefully you caught them. Okay. So, ang A cross B ay set lang na lahat ng mga ordered pairs na yung first components ay nanggagaling kay capital A, lahat ng second components ay nanggagaling kay capital B. Now, if we will take a set or a subset of A cross B, what we get is a relation. Okay. So, ito yung sinasabi ng definition 1. Okay. So, a relation, let's call it rho. Okay. So, yung relation rho from A to B is just any subset of A cross B. So, para lang tayo ay magkaroon ng relation, kukuha lang tayo ng isang specific subset ng A cross B. So, napaka-generic ng konsepto ng relation. So, for instance, if we set the set A to be the set containing O, E, and V, and the set B to be the set containing H, comma, K. So recall from your lab discussion yesterday, ang A cross B lamang ay set ng lahat ng ordered pairs na yung first component ay nanggagaling kay set A, second components nanggagaling kay set B, and I hope you already discussed, or if not, I hope you can imagine that the cardinality, hindi pa pala natin na-define yung cardinality, pero yung dami ng members ng A cross B is just the product of the members of A, or the number of members of A and the number of members of B. So here A has 3 members, B has 2 members, so we expect the Cartesian product to get 6 members. Okay? So ang nasa Cartesian product ay lahat ng ordered pairs na yung first elements ay nanggagaling kay A. So lahat dapat sila ay ang mga first components ay O, E, and V. All right. Second components mo ay H and K, and you take all possible combinations. So ibig sabihin si O, ipe-pair ko siya kay H, getting the first element. Then si O, ipe-pair ko kay K, getting the second element. E is paired to H, then E is paired to K, and so on. Kaya natin makukuha yung 6 members. So gamit ka lang ng fundamental principle of counting para makuha yung total number of elements ng cross product. So this is our cross product, and if you take any subset of the cross product, then we get a relation. Okay. So if we define rho, for instance, to be the set containing OH, OK, EK, and VK, we say that rho is a relation. Kasi lahat ng elements ni rho ay na kay A cross B. Or in other words, this set rho that we considered is a subset of A cross B. So isa siyang relation kasi subset siya ng cross product. So we say that rho is a relation from A to B. Okay. Yung prepositions from A kasi siya yung mga first elements. Tapos papunta kay B kasi si B yung mga second elements. So basically, it's as if we are drawing up a relationship between the elements of A and the elements of B. Kaya ang tawag sa kanya ay relation. So you can think of it as O is related to H, O is related to K, E is related to K, and V is related to K. Kasi nga, merong mga ordered pairs dun sa row na kung saan ordered pairs si O at saka si H, O si K, E at saka si K, at saka si V at saka si K. All right? So we say it's a relation from A to B simply because it is a subset of A cross B. Right? Now another one is curly R. If we define curly R to be the set containing OH and the ordered pair E comma H, then it is still a relation from A to B. Kasi kasi ito obviously ay subset ng A cross B. So since it is a subset of A cross B, then it qualifies as a relation from A to B. Right? Of course, you can define other operations on, other relations on A cross B or from A to B by simply taking relations or actually taking subsets of A cross B. So, ibig sabihin, ilan ang posibleng candidates natin para maging relations? Anyone? Ilan yung possible relations kay A cross B? Possible relations from A to B. Can you guys think of it? Sinong may hula? Ilang posibleng relations ang pwede nating makuha? Dito may dalawa na tayong example, si Rho at saka si Curly R. Yes, Mitzi?
Sir, wala lang po. Ano po? Bale, 2 raised to 6 po, 64 po. Wala
Okay.
lang po, sir.
All right, that's perfect, Mitzi. So 2 to the 6th or 64. Bakit mo nasabing 2 to the 6th?
Kasi gawa po nung nabanggit po dati yung number of subsets po ng isang set ay 2 raised to n po.
Okay, perfect. So sabi nga natin, ang mga relations lamang ay kahit anong subset ng A cross B. Si A cross B natin may 6 na element and Mitzi is right. Napakita natin last time, though without proof. Hindi ko pala na-prove, no? Siguro yun na lang ang ipagawa ko sa problem set. Okay, so i-prove ng ang number of subsets of a set ay 2 to the power n. So you can start looking up for it or attempting to write a proof for it and then sasama ko siya sa problem set, okay? Kasi pinangako ko nga pala na iprove ko siya pero hindi ko siya nagawa. Okay. So meron kang 2 to the 6th possible subsets and each of these subsets is a relation from A to B. So 64 yung posibleng relations dito. Okay, so you can draw up some examples of relations by simply picking up subsets, okay? Pero I think that should be easy. So remark 4 actually gives us another notation. So if the order pair O comma K is in row, okay, we can say that O is row related to K. So pwede natin siyang isulat this way. So kung meron kang relation row, okay, tapos yung ordered pair O comma K ay na kay row, so pwede natin siyang isulat this way. Okay? So you have the first element followed by the name of the relation and then the second component. So ang basa natin dito ay O is related to K, or if you're talking about multiple relations in context, so pwede nating further qualify yung pagbasa nito as O is row related. So yung pangalan ng letter, row, then related. O is row related to K. In the same manner, kung matatandaan niyo yung set curly R natin kanina, E comma H is an element of curly R. So we can say that E is related to H via curly R, or we can say E is curly R related to H. So this is another way of writing relation without referring to them as ordered pairs. So yun nga lang, yung nasa kaliwa, siya yung laging first component, yung nasa kanan, siya yung second component. Because in some relations, hindi necessarily na related pa rin sila pag pinagbaliktad mo na yung dalawang elements. So be careful about that. Again, because ordering matters here. Yung mga elements ng relation ay mga ordered pairs. Okay? Now, another definition here, we define the domain of a relation. So the domain of a relation is denoted by D with a subscript, the relation name. Okay? So kung gusto kong kunin yung domain ng relation row from a set A to set B, i-denote ko siya by D sub row. Okay? And this is simply the set of all first coordinates in row. So tingnan mo lamang lahat ng mga first components dun sa relation row, kolektahin sila sa isang set, then yun yung domain ng relation. In other words, the domain of the relation row is the set of all x's such that x is row related to y for some y in B. So, ibig sabihin, basta nag-serve siya as first element dun sa mga ordered pairs, kasama na siya kagad dun sa domain regardless kung sino or ilan yung correlated niya dun sa uh, relation. Okay? So it doesn't matter kung tatlo yung related sa kanya, apat yung related sa kanya, isa yung related sa kanya, that's fine. It is automatically part of the domain. Okay? Now, if we go back, all right, siguro bago natin balikan yung example, tingnan natin yung definition 6. Definition 6 defines the range of row. So there's a typo here, of course. We should have adopted a different notation for the range. So tawagin natin siyang R sub row. Okay. So capital R for the word range. The subscript will denote the relation row for which we are computing the range for. So ang range R sub row ay siya naman yung laman ng lahat ng second components or second coordinates sa ordered pair. So again, row of R sub row, kokolektahin lang natin lahat ng second elements. So we're looking for all y's such that x is related to y for some x in capital A. So again, kolektahin lang natin lahat ng first components. So if we go back to our examples earlier, okay, so si row ay ito. So ang domain ni row ay lahat lang ng first component. So it's going to be O, E, and V, which happens to be the set A. And then its range, the range of row, is the set of all second components. So that's going to be H, comma, K. And this incidentally is also B. All right? Tapos kung kay curly R naman tayo, so ang domain ni curly R ay set containing O and E, right? And then ang range naman ni curly R ay set containing H, which are proper subsets of A and B respectively. Okay? So sa isa palang relation from A to B, yung domain ay hindi necessarily equal kay set A, nor yung range ay necessarily equal kay set B. So basta ang usapan ang domain at saka ang range ng isang relation, kolektahin lang natin lahat ng first component, tapos kolektahin natin yung set of all second components respectively, and then we'll get these two sets. Okay? So is everything good so far? Puro definition pa lang, no? Okay. Now, another terminology. Okay, Daniel?
Sir, nalito lang ako sa definition ng range and domain. Bakit po sinabi na pong may relation, pero bakit sinabi pang for some x an element of A? Di ba na-define na yung mga elements ng row gamit sa relation?
Well, dito sa pagkakasulat ng definition, wala siyang inassume na relation kagad. So, parang ano lang siya, parang formalization ng statement.
Okay.
So, maging element siya ng domain kapag ka si X, okay, ay nag-serve as a first member ng mga ordered pairs. Tapos, maging element siya ng range kung siya ay Y, siya ay nag-serve as a second component ng relation. So finormalize lang siya talaga. Pero essentially, what these two definitions tell us ay kunin mo lang lahat ng first components and then this guy is just the formal way of saying it. Kunin mo lahat ng first components para sa domain, kunin mo lahat ng second components para kay range. Okay?
Oh, okay, thank you, sir.
All right. So kung medyo nakakalito yung technical definition, you can think of it as using the intuitive notion. Okay? Kinolekta ko lang lahat ng first components, kinolekta ko lahat ng second components because as long as you understand what the domain and the range means, then you don't need to go back here for now. Okay? Siguro pagka na-develop nyo na pag nasanay na kayo sa set theory, magiging mas familiar na kayo sa technical definitions nito. Pero if not, then okay na ako na alam nyo yung spirit ng domain at saka ng range. Okay? Now, definition 7 just gives a special name for a relation from a set A to itself, right? So when you're defining a relation from a set A to a set A, so basically you are defining a subset row of A cross A. Ang tawag dito, instead of a relation from A to A, you can also say that it is a relation in A. Okay? So iniba lang natin yung proposition. Instead of saying it's a relation from A to A, you can say it's a relation in A. All right? So an example of a relation in the set A containing all the letters in the word love is the relation sigma. Okay? Where in here we say that O is sigma related to E, so you can write ordered pair 0, O, comma E to be in sigma. All right? Kasi obviously naman, ito si sigma, ang laman niya ay yung apat na ordered pairs, okay? And one of these ordered pairs is O, comma E. So you can say this. Or if you don't want to talk in the language of ordered pairs, you can also write O is sigma related to E. Okay, so that's another way of writing this same thing. Okay, so bahala na kayong pumili ng pagkakasulat. And obviously, this set sigma is a relation in A kasi lahat ng first components niya nanggagaling kay A, lahat ng second components niya nanggagaling din kay A. All right? And then, can somebody tell me what is the domain of sigma? Aside from Mitzi, nakasagot niya si Mitzi. Ano yung domain ng sigma at ano yung range ng sigma? Okay, Gat.
Domain po is OVEL.
OVEL. So that incidentally is the set capital A. Thank you. Thank you, Gad. How about the range? So can somebody else give me the range? Yes, Alisa.
Yung range po is EOV.
EOV. Okay, that's perfect. So ang range niya ay proper subset ni capital A. So hindi necessarily, again, sabi natin, hindi necessarily lahat ay kasali sa domain at saka sa range. Okay? So that's perfect. Another illustration here. So usually relations can also be defined instead of a roster notation wherein we are just enumerating all elements of the relation. Pwede rin siya naka-set builder notation. That is, we are giving a test or a property that elements of the relation will and should satisfy. So an example is in illustration 9. We consider the set A to be the set containing 1, 2, 3, and 4. And then we define the relation row in A by this requirement. X will be row related to Y if and only if X is greater than or equal to Y. Okay. So in set builder notation, pwede natin siyang isulat as row to be the set of all ordered pairs X, Y coming from A cross A. Ito yung universal set natin kay ZF3. And then yung property P about X and Y is that X must be greater than or equal to Y. Okay? So si X ay magiging related lamang kay Y kapag ka si X ay greater than or equal to Y. So that's why 1 is related to 1 because 1 is greater than or equal to 1. So again, ang requirement, dapat yung unang component ay mas malaki kesa dun sa second component or equal dun sa second component. So that's why 2 comma 1 is in row, 3 comma 1 is in row, 4 comma 1 is in row, 4 comma 1 is in row, and so on. But you will see that say 1 comma 2 is not in row kasi yung first element ay strictly mas maliit kesa dun sa second element. So by the way, this is our common notation, set notation para sabihin na hindi siya kasali dun sa set. But in the context of relations, you can also say that 1 comma 2 is not, or 1 is not related to 2. Okay? Or you can also write it as this. 1 is not row related to 2. So yung pangalan ng relation, lagyan nyo lang ng slash. Okay, para hindi siya maging element ng relation. And then again, if we collect the domain and the range, we'll just be collecting all first components and all second components. And it is not hard to see that the domain and the range are both equal to A. Okay? Questions? Everything's clear? Okay pa naman yung examples? Sige, let's see another one. Oh, Victor, you have a question?
So sir, specific example lang to.
Yep.
So hindi naman ganito sa iba. Like yung x greater than equal to y. That's just a parang assumption na lang here for this example.
Right. Yeah, that's a specific example ng isang relation row na define using a property P about x and y. So you can give any other property here, basta about x and y siya. So magbigay ka lang ng requirements, kailan nagiging related yung isang element ng domain sa isang element ng range. So this is just one specific example. And siguro bigay pa tayo ng ilang specific examples or tangible examples. Okay, so another example ay yung nasa exercise 10. So sa exercise 10, binaligtad naman. So same set A, pero yung relation tau in A is defined to be x is tau related to y if and only if x is less than or equal to y. So ang titingnan naman natin dito, ang requirement para maging member ni tau, alright, ay dapat yung unang component ay mas maliit or equal dun sa second component. So can you name some elements of this relation? Any volunteers? Okay, Marnie, give me 2 elements of the relation tau.
Hello po.
Hi.
Pwede po yung 1, comma 1 po.
Okay, and then another one.
1, comma 2 po.
1, comma 2, and so on, right? Thank you, Martin. How about non-members of this relation? Okay, before I call Jan Rensis, Esther is right. 1, comma 3 is also a member of Tau. So the JR, sorry, hindi pala si, tama ba? Yeah, Rensis. Rensis yata yung nickname niya. Rensis, non-members?
Non-members po is 4, 1, 4,
Okay.
2.
4, 1, and 4, 2 are examples of non-members of the relation tau. Kasi hindi nila na-satisfy yung defining property ng ordered pair. Okay? Thank you, Rensis. Now, another example, isa pang relation, hindi laging inequality yung defining characteristic. Actually, the defining characteristic can be arbitrary. Kaya minsan mas okay yung roster method, lalo na kung random lamang yung pag-associate natin o pag-define ng relation. Okay? Now, kaya hindi kailangan less than or equal to, greater than or equal to siya. It can also be an equality, or actually sabi ko nga, it is anything under the sun. But in example 11, it gives us a relation in U, but U is, or actually U pala yung tawag dun sa relation. And it is a relation in the set of real numbers. So it's a subset of R cross R. So the set U is a subset of R cross R kasi sabi relation siya in R, okay? And the defining characteristic for ordered pairs in the set U or in the relation U would be that X and Y, okay, must be real numbers such that X squared plus Y squared is equal to 1. Okay? So yun yung criteria natin para maging member ng relation U. Some examples of this ordered pairs would be 1, 0 and 0, 1. Of course, you can also have root 2 over 2, root 2 over 2. What are the other members? Pwede rin ng yes, Mary Rose. Can you give other members of U?
Sir, pwede po ba yung 1 over 2, comma, square root of 3 over 2?
Okay, yeah, that's right. That could also be a member of this because pag ini-square mo yung una, in-add mo siya dun sa square ng pangalawa, you'll get something equal to 1. Actually, if you have here, you can also add negative signs, right? Negative 1, 0 and 0, negative 1 are also members of the relation U. Pati yung negative square root of 2 over 2, negative square root of 2 over 2, they are also members of this relation. Actually, this relation, kung matatandaan nyo sa algebra, x squared plus y squared equals 1, it gives us a circle, right? So yung circle, yung unit circle, so sila yung lahat ng points sa unit circle. So halimbawa, ito yung origin, okay? So alam natin, magiging element siya or maglalay siya dun sa circumference ng circle if x squared plus y squared is equal to 1. So any point on this unit circle will be a member of the relation U, okay? So, or if you have an element x comma y here, we say that x is related to y via the relation U, okay? So 1, 1, for instance, is not in the set U because if we square 1, add it to the square of 1, we get 2 not equal to 1. So hindi nyo na-satisfy yung defining property. Okay? So yun yung isang relation. And this is a nice example of a relation defined on an infinite set. Okay? Kasi nga, ang set natin dito ay R cross R. So kumuha ka ng subset ni R cross R, and then this particular subset will contain infinitely many members, okay? In particular, it will contain all points on the unit circle. So posibleng infinitely many pala yung elements ng mga relation natin. Okay. So what would be the domain and the range of U? So anyone? What's the domain of U? And what is the range of U? Okay. Dapat pala subscript yung... Okay. Kelvin? What's the domain?
Hello po. Sir, rinig po.
Hi.
Sir, ano po, yung sa domain po, I think, ano po siya, yung set, ano po, negative 1 to 1. Kasi since sinabi niyo po na pwede pong infinitely many yung points na possible.
Okay, that's right, Kelvin. So I think you're saying the closed interval,
Included
negative
po
1.
yung, included yung 1 at negative 1.
Okay, perfect. That's right. Kukunin kasi natin lahat ng first element niya, right? So kung meron kang element, kasi ang gusto natin ay x squared plus y squared equal kay 1. So kung kukunin natin lahat ng posibleng members lahat ng posibleng first component, so we'll be looking at the all possible values of x, right? So kung graphically, madali pala siyang makita kasi kung titingnan niyo siya sa Cartesian plane, titingnan lang natin lahat ng first components niya. Ibig sabihin, kukunin ko lang lahat ng numbers na nadaanan sa x-axis. Alright? So that will be from negative 1 until positive 1. Ganun din yung range. So titingnan natin lahat ng y values. Nagsimula siya sa negative 1, nagtapos siya sa positive 1. Okay? So that makes the range from negative 1 to 1. But if you want to be more analytic about it in taking the domain and the range, pwede naman tingnan ano yung mga posibleng values ni x at saka ni y. Okay? So we know that the defining characteristic is that x squared plus y squared equals 1. So computing ko lang lahat ng posibleng values ni x squared. So pwede siyang maging x squared equals 1 minus y squared. Then we take the square root of both sides, we get x equals plus or minus square root of 1 minus y squared. Okay? So ibig sabihin ganito dapat yung maging laman ng ito yung mga posibleng values ni x, alright? Pero ano bang alam natin dito? Well, dapat yung nasa loob ng radical para maging real number siya, this should be less than or equal to 1. Alright? So minimum value nito ay 0 kapag ka si y ay equal kay 1. Tapos ang maximum value niya ay si 1 lamang. That will happen when this guy is equal to 0. Okay? Tapos hindi tayo pwede makakuha ng number na nasa labas ng interval negative 1 to 1. Kasi nga sabi natin gusto natin ito ay laging positive. Alright? Para hindi tayo magkaroon ng imaginary number. So if we will get, so this is always positive. And then the minimum value is 0, the maximum value is 1. So here we'll get a number between negative 1 and 1. Kasi yung minimum value niya ay negative 1, yung maximum value niya ay positive 1. Kasi ito ranges from 0 to 1. Pag nilagyan ko siya ng plus or minus sa unahan, we can go as far as negative 1 to the left and as far to the right as positive 1. Okay? Pero siguro mas madali yung graphical thinking dito para makita yung domain at saka yung range. Okay? Now, as I've mentioned, these are just specific examples of relations. Meron pa mga ibang mga klase ng relations and actually these are some of them. Equality of numbers, membership in a set, alphabetical order of words. So ibig sabihin niya lang ay pwede mo sabihin na x is row related to y if and only if x comes first in alphabetical order, or x is or if x goes after y in the alphabetical order. Okay. Tapos ito palang membership sa set, okay din tong relation. So we can say that x, an example is x is row related to capital Y if and only if x is an element of y. Posible palang ganito rin yung definition natin ng relation. Si object x ay related kay set y if and only if x belongs to y. So for instance, if this is our relation, I can say that 1 is related to the set R. Okay. I can also say that 1 is row related to the set Q. Okay. Kasi si 1 ay element din ni Q. But I can say that pi is not row related to Q. Kasi si pi ay hindi rational number and so on. So nakikita nyo, napakalaki ng market, nung definition natin ng relation. We can define the relation as arbitrarily as we want, okay? So to the point that we can define the relation between an object and a set, okay? So halimbawa rin, pwede mo ring sabihin na the set Z is not row related to the set Q kasi ang usapan dapat yung nasa kaliwa ay element nung nasa kanan. Pero si Z, hindi naman siya element ni Q. Posible mo sabihin na si Z ay subset ni Q, pero si Z ay hindi element ni Q, so hindi pa rin nila na-satisfy yung defining characteristic nung row. Okay, nung relation row. Okay? So pwede nating, or you can further define, kung gusto mo talagang si Z ay maging related kay Q, pwede mong i-define yung subset or inclusion. You can say that X is row related to Y if and only if X is a subset of Y. Okay. Now, parallelism of lines is also a nice example of relation. Measurements, comparison of measurements is also a nice relation. Tapos yung among circle of friends or persons, pwede mong i-define yung relation for as friends and enemies. So you can say that X is related to Y if and only if X is an enemy of Y. And so on. So napaka-abstract ng konsepto natin ng relation. Hindi lang siya sa numbers. Hindi lang siya sa objects, pwede siya sa persons or any set. Okay. Now, another nice relation that we might see later is the congruence relation in the set of natural number, in the set of integers. And we say, ang tawag natin dito sa relation na to ay congruence modulo. So ito ay congruence. Okay. So we say that x is related via congruence to y if and only if, sorry, mali pala yung sinabi ko. Ito pala notation na to ay ginamit para sa congruence. So this is a symbol for congruence. All right. We say that x is congruent to y modulo n if and only if n divides x minus y. So probably I'll end here sa pag-illustrate nitong congruence relation kasi makikita uli natin siya later. So here we say that, okay, so we can define rho. X is rho related to y if and only if x is congruent to y modulo n. And congruence modulo n is defined this way. You get x minus y, and you see if that is divisible by n. So for instance, I can say that, say what? 4 is rho related to 4, since 4 minus 4 equals 0 is divisible by, that pala specify kung ano si n, all right? So, halimbawa, okay, sige nga, ayusin ko na lang siya dito sa next page. Okay. So, we will say we define x is rho related to y if and only if x is congruent to y modulo 3, halimbawa. Okay. So, in this relation rho, I can say that 4 is rho related to 4 since 4 minus 4 is divisible by 3. Okay? Kasi ang 4 minus 4 ay 0, and 0 can be written as 3 times 0. Remember yung relation that divides, okay? So we can say that n divides a number, say a number a, if and only if a can be written as an integer times the divisor n, okay? For some integer k. Okay? So, yun yung definition natin ng divides. And if you look at 4 minus 4, siya ay divisible by 3 kasi si 0, which is 4 minus 4, can be written as 3 times another integer. Okay? Another example of elements of this relation would be 4 and 1. 4 is rho related to 1 because 3 divides 4 minus 1, which is equal to 3. All right. So the difference of 4 and 1 is divisible by 3. So ito kaya sila ay related under the relation rho. Also, say 1 is also related to 4 because 3 divides 1 minus 4, and 1 minus 4 is negative 3. Okay. Now, can you give me a non-member of this relation rho? Sige, you can choose if you want to give me a member or a non-member. Anyone? Last questions and thought for today. Okay, so Esther suggests, okay, LG, bago ko puntahan yung sa chat. You want to give an example or a non-example?
Non-example na lang po.
Okay.
Non-example is 7 rho 2.
Okay, 7 is not rho related to 2, all right? Because if you look at 7 minus 2, that's equal to 5, which is not divisible by 3. Okay. And then in the chat, Esther suggested 1 is not rho related to 5. Okay. Kasi ang 1 minus 5 ay negative 4. Si negative 4 ay hindi divisible by 3. Also, Victor suggested 2 is not row related to 4 kasi ang 2 minus 4 ay negative 2, hindi siya divisible by 3. Now we can say that what? We can say that 37 is row related to 4. Another example, because 37 minus 4 equals 33 is divisible by 3. Okay? So babalikan natin to, pero yung crucial sa congruence relation ay mabigay kung ano yung value ni n. Okay? Kasi posible itong mapalitan by any integer. So you can define the relation row to be congruence modulo 7 or congruence modulo negative 3 and so on. Okay? Pero yung definition ng congruence, dapat yung difference x minus y must be divisible by n. Okay? Perhaps we'll look at some examples of congruence relations later kasi isa siyang basic example ng equivalence relations. So, what are equivalence relations? Though, na-spoil ko na kayo last week kung ano yung equivalence relation, but we'll be looking at examples of equivalence relations and some properties of equivalence relations next time. Okay? So I think I'll end here. Do you guys have questions before we leave? Clarificatory questions or questions about the prob set or about worksheets? Wala naman? Okay, so if you're none, those who recited verbally, please comment your name on the chat or your nickname on the chat so I can record them. Ano pa ba? Oh, I think that's it for now. So enjoy the rest of the day, guys, and then let's see each other again on Thursday to hopefully finish this study guide. Okay? Bye, guys.
Thank you,
Bye,
sir.
sir. Thank you po.
Thank you,
All
sir.
right.
Sir.
Thank you po, sir.